Alright, welcome to Unit 4, Chemical Equilibrium. Finally, we're at equilibrium. We're done with a lot of random vocab, but we can actually start doing useful stuff. Alright, here we go. So, many reactions, like all of them, many reactions are forward reactions, which means that reactants form products and then the reaction ends. Most of what we've talked about so far, or at least have seen, we're pretending are forward reactions. Meaning, you start with reactants, you go to products, when one runs out, it's done. A lot of things you can think of are likely forward reactions. However, a lot of things in chemistry that actually regulate our life are not just forward reactions. Some reactions are reversible. This means the reactants form products, but then the products actually react and reform those reactants. You end up having, you got reactants and you got products. So yes, these are forming products, but they're also forming reactants. You end up having this kind of back and forth motion, if you will, going. So we write these reversible equations with a double arrow. So all this equation, two arrows pointing right and left. Typically, we call the direction to the right our forward reaction. That'll come in handy a little bit. As you can tell, I'm using my bad stylus again. And we also call the reaction typically going to the left our reverse reaction. So that's reversible equations. It's just when you've actually got two arrows. Now, as this reaction reacts, it'll eventually reach a point of what we call chemical equilibrium. That is a very important term. I can almost guarantee you it will be on your test. Chemical equilibrium, which is a point at which the forward reaction rate and the reverse reaction rate are equal. That does not, for those still not paying attention, does not mean they are zero. It means they are equal. Okay, it doesn't matter what the rate is. It doesn't matter how much of reactants and products you have. It matters when the forward rate and the reverse rate are equal. That can happen if you have no reactants. That can happen if everything you have is reactants. That can happen somewhere in between. It doesn't matter. You'll actually hit a point where basically your concentration of reactants and products will no longer change. You'll hit a stalemate because anytime something is made to a product, it's then turned right back into a reactant. That is equilibrium, when the forward rate and reverse rate are equal. Doesn't matter what number they are equal. Now, if they're both zero, yeah, that's kind of a really boring equilibrium. Typically, they're not. It's when they're equal. That again means that the reactants will form products at the same rate as the products reform into reactants. That is chemical equilibrium. When they have the same, when the forward reaction rate is the same as the reverse reaction rate. All right. That, however, that's our entire video. Thanks for watching.